Hello everyone, welcome to CS30. For this lecture video, our goal is to talk about arguments. And when do we say that an argument is valid or not? We have two lecture videos for this, and this is the first part. I think this is a very important topic because we can use this to validate information and counter fake news. So first step when validating information is to list them down. So let's say we have the following. If interest rates drop, the housing market will improve. Either the federal discount rate will drop or the housing market will not improve. Interest rates will drop. Therefore, the federal discount rate will drop. So is this correct or not? We can apply logic and investigate the truth of this claim. So first, we identify the basic statements from the argument. What are the basic statements? Interest rates drop. The housing market will improve. The federal discount rate will drop. This one, the housing market will not improve, can just be obtained from this one. This is the same as this one, and this is the same as this one. So we have three basic statements. Let us now use symbols to represent these statements so we can focus on the logic. Here, we use these symbols to represent these basic statements. And now going back to the claim, if interest rates drop, the housing market will improve. How do we represent this in symbolic form and using these basic statements? So here we have if I, then H. Next, either the federal discount rate will drop or the housing market will not improve. We are using the term or, so we have to distinguish if this is the inclusive or the exclusive or. So the federal discount rate will drop can be true, and the housing market will not improve can also be true. Can they be both true? It seems they can be both true. So we will interpret this as the inclusive or. So if this is inclusive or, how are we going to represent this in symbol form? So this is F or not H, because we have the not here, which means negation. Next, interest rates will drop. So for this one, this is just I. Therefore, the federal discount rate will drop. This is just F. So how are we going to join them all together? Note that the first three statements are used to conclude the fourth. So in symbols, we can say this and this and this imply this. In symbol form, it's this one. So we take the conjunction of the first three statements and use it as premise for the fourth. Let us formalize what we know so far. An argument is a well-formed formula having the following form. So here we have a conjunction of statements that imply some conclusion. Following the terms for conditional, we will also call this premises, and this is the conclusion. How do we know if an argument is valid? An argument is valid if it is a tautology. So this means when for all truth combinations of the premises and conclusion, the argument is always true. Let us recall the form of an argument and remember lessons that we learned in previous lecture videos. So first, a conjunction of several statements is true only when all the statements are true. Also, a conditional is false only when the premise is true and the conclusion is false. So, what does that mean? Let's say this is true, so the premises are true, and this is false. So, this is the only case where this conditional will be false. So, from there, what do we know? An argument is invalid only when there is an instance where all the premises are true, so P, but the conclusion is false. So because with that, we will have a false conditional. If such a situation cannot occur, the argument is valid. How do we prove that an argument is a tautology? So, as given here, there are two ways. Use the truth table or use formal logic. So, let us explore the first option, analyzing arguments using truth tables. So, here are the steps. First, translate the premises and the conclusion into symbolic form. Write the truth table for the premises and the conclusion, and then determine if there is a row. So there is at least one row in which all the premises are true and the conclusion is false. If yes, the argument is invalid, otherwise it is valid. So let us consider an example. Mary studies hard. If Mary studies hard, then she is a nerd. If Mary is a nerd, then she does not party. Therefore, Mary does not party. So, our goal is to determine if this is valid or not using truth tables. As mentioned, the first step is to convert all of this to symbolic form. So, how do we do that? We first identify the basic statements. So, what are the basic statements here? First, Mary studies hard. So, that's one basic statement. This is also a basic statement. She is a nerd. This is another basic statement. Mary does party. So, here are the basic statements, and we assigned symbols, one for each of these. We can now convert the premises and conclusion to symbolic form. So let's start with this one. This is just P. And then this one, if Mary studies hard, so this is P, then she is a nerd. So P implies Q. If Mary is a nerd, so Q, then she does not party. So if Q, then not R. Therefore, Mary does not party, so not R. We are using this symbol to represent therefore, and also to distinguish the conclusion from the premises. So we are now ready to construct the truth table. So let's just remember this. List down the basic statements and the premises and conclusion. So we have to first fill up the table. So we have to first make sure that we list down all the possible truth assignments for the basic statements. So false, true, and then false, false. So let's say this is true, 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 and then copy all of this here, and then set this to be false, false. Okay, so let's evaluate not R. So this is false, and then this is true. So notice that there is a pattern here, so we can just copy this here and copy this here. So P implies Q. For all the cases where P is true, so this is the only case where it will be false. So here it is false, and then this is true, and then this is true. So since P is false, so we can we know that these are all true. Next, Q implies not R. So this is false, true and true. True implies true, so this is true. False implies false, false implies true. True implies false, so this is false. True implies true is true. False implies false is true. False implies true is true. So all of this is true. There. So what do we do next? We identify the premises and the conclusion because we are interested in them in this truth table. There. So we already colored yellow those that are premises. So that's P. P implies Q, and Q implies not R. And then we colored the conclusion red. So now, what do we do next? We check for the rows where all the premises are true. So first row, no. Second row, yes. All the other rows, no. So we are only interested in this row where the premises are true. And then we check the truth of the conclusion. Here, the conclusion is also true. So there is no row where all the premises are true, but the conclusion is false. And so we can say that this argument is valid. Okay, so let's go back to this example. Please practice and check if this argument is valid or not. That concludes this lecture video. In the next lecture video, we will talk about proving the validity of arguments using formal logic. So see you in the next lecture, and thank you for listening.